Black hole is one of the most popular and fascinating topics for both space enthusiasts and the general public. But they are also one of the most complex and difficult subjects to understand in all of physics. Countless science fiction films have been made about them. Most of them use black holes as a plot element to somehow distort time. If you went to a coffee shop or bar and asked a stranger to explain about black holes, so they can give you a brief version of Interstellar, which will explain how time slows down as you get closer to the black hole. But it is unlikely that the average person will be able to explain to you why time slows down near a black hole. And why does it actually stop inside the black hole? This is what this video is about. By the end of this, you should have a clearer and simpler understanding of black holes. So if some random person comes up to you in a bar or coffee shop, hopefully you can waste a few months. And the first thing you need to know is that a black hole is not an object. Even though they are often depicted as huge black spherical balls floating in space, black holes aren't necessarily things you can touch. Rather, they are the result of extreme curvature of space-time. And because of this curvature, some very strange things start happening in physics. Black holes themselves are so strange that if there is no solid mathematics to explain their existence, and the effects on space-time, as well as the continuous and new observations to support that math, are emerging, we would only consider black holes as more than just a science fiction plot device. But they are very real, very dangerous, and they can be very, very large. By the way, black holes come in all sizes. Some of them are as small as atoms, but those black holes are too small to maintain their size. The smallest known black hole that maintains its shape has a mass about 3 times that of our Sun. This measurement is also known as solar mass, but the largest of them can reach up to billions of solar masses, easily fitting our entire solar system inside them. For example, the extremely massive black hole Ton 618 is the largest confirmed black hole in the universe, and its mass is 60 billion solar masses. And for reference, that small point is the size of our entire solar system. The internet is surprisingly obsessed with this theoretical black hole keyword, which is being theorized here. The theory of the black hole keyword is given here. It is currently estimated that Phoenix is even larger than 618 tons. Phoenix could be as massive as a black hole with 100 billion solar masses, but that number is not yet confirmed. Officially, more research is needed to keep Phoenix at the top, that black hole list. But how do black holes form even though they can vary in size? It doesn't really matter that much. They are primarily formed in one of two ways. Either a lot of material is pulled into the core of a star during its collapse. This is how a neutron star is sufficiently acquired. The mass of the material has to be about 2 to 3 solar masses. However, there are some differences between those two examples. The formation of a black hole always falls into one of these two categories. Okay, so now that we've talked about some basic facts and understanding about black holes, let's get to the really weird stuff. Why does time appear to be completely stopped in a black hole? This is the easiest way to imagine how a black hole can impact space. Think about a very large and really deep trench. A circle so deep that you can't see its bottom and you're not entirely sure if it even has a bottom. This is effectively what black holes are doing to the fabric of space. The gravitational force is so massive and concentrated that it is causing a heavy fall in space to such a depth. It appears to be a circle with a gradual slope without any end. We can't physically see that dip in space. This is because it exists in a circle in a higher 4th dimension, and we can only see things in the 3rd dimension. Just like if you wrap a basketball because we live in, you'll be able to see it fall to the ground, bounce, and return to your hand, without assuming that the shape of the basketball has changed at all. However, If you want to imagine a basketball falling on a crumpled piece of paper, so you make the ball a little smaller, so that it looks like it is farther from you, and a little bigger. To show that it is approaching you, you need to change the dimensions of the ball to give a sense of angular motion in the clock position. And something similar happens when motion is observed in four-dimensional space by those who can only observe things in three dimensions. When an object is rotating in the higher fourth-dimensional plane, instead of converting the dimensions of the object in three-dimensional space, we are seeing that the time of the object is being manipulated. The object will appear to be slowing down or merging. So, if you are a visual learner like me, this would be the section you'll really want to pay attention to. So if you imagine a photon of light traveling towards this dip in space in four dimensions, you will see that the photon went down in that dive.
But in three dimensions, it's almost like looking at a crumpled piece of paper.
As the photon travels downwards in space, we are not experiencing changes in the dimensions of photons. It appears that light is slowing down due to our lower dimension, because the speed of that white photon is not changing at all. Only our perception is changing of how it is interacting over time. So say it again, in simpler terms, from Dodi's perspective, whether it's a photon of light or a person's body going into a black hole, the outer observer is more or less seeing the light or object descend into the fourth dimensional plane. The speed of the light or object caught in the black hole hasn't changed at all. However, to an external observer viewing this event in three dimensions, it appears as if things inside the black hole are slowing down. In this way, black holes can manipulate both space and time. If you are able to approach the black hole, you would start diving into the circle created in space-time. But time will not seem different to you at all. It will only seem different to those who are not near the black hole. This means that the effect of a black hole on time is relative. What is happening to you near the black hole is not happening to someone on Earth. They feel that you are moving slowly, but you feel that they are moving fast. So, near a black hole, time slows down. Does it eventually freeze at some point within the black hole? Or does it move so slowly that it appears to be at a standstill? Once you reach the event horizon of the black hole, it is the point where gravity is so strong that space is rotating at the speed of light. This is where our perception of time takes shape, because the velocity is constantly changing. The universe is rotating at the speed of light. So, to an outside observer, it will appear that the light is at a standstill beyond the event horizon. There is no point of return, and a black hole does not necessarily mean that time stops, but rather where time stops. And I can't stress this enough. This notion of time slowing down or stopping is relative. If you somehow manage to survive passing through the event horizon of a black hole, you would experience no different passage of time. But for an outside observer, if somehow they were able to see you inside the black hole, you would appear as if you were frozen in time forever. And all this is because space-time is moving at the speed of light. And keep in mind that this is a highly simplified version of a very complex topic, which also involves some very complex mathematics. The devil is indeed in the details. In this case, the devil is a black hole, but hopefully, this gives you a slightly better understanding of what a black hole is, and its devastating effects on the universe and space-time. So next time when someone is talking about an interstellar or black hole in general, so you'll have more depth to add to the conversation. And if people are interested in all these things, subscribe to Astroverse.